Okay, so today what we're going to do is we're going to add and subtract radicals. And here's what I want you to think about before we even get started. I want you to think about radical 5. And if you think about radical 5, you go, I know it's a number, but I don't know what number it is. Radical 5 is essentially a variable. Because if you think about the definition of a variable is some number, or it's a letter that represents some number, but you don't know what that number is. So radical 5 is essentially a symbol to represent some number that you don't know what it is. Now you can approximate that number. That number is around 2, like 2.1. Like if you get a calculator, you can take it and you can take in 5 and take its radical, and it's 2.2 something. But again, it's some number that you're not quite sure what it is. So I want you to think about, whenever you think about like radical 5 or a radical that you don't know what it is, we're just going to pretend like that's an x. And then we're going to do some of the problems today. So here is the first problem that we're going to deal with. Let's deal with this problem right here. 3 radical 5 plus 4 radical 5. Now again, from before, I told you to think about radical 5 as just being some number. We don't even know what number it is. So let's rewrite this and make it a different problem that I bet most of us would know how to do. What if I wrote 3x plus 4x? Well, most of you guys would go, oh, that's 7x. That's the same way you deal with radicals that you don't know what's happening. You have 3 radical 5 and 4 radical 5. So you would say this is 7 radical 5. Because radical 5 acts like an x. Let's do a second one. So let's say I have 2, whoops, didn't work out too well. Let's say I have 2 radical 7 plus 4 radical 7. Well, again, I have no clue what radical 7 is, or what this radical 7 is. All I know is that it's some number. Well, I know what 2 plus 4 is. 2 plus 4 is 6, and then again, radical 7 just kind of stays the same. Let's try another example. Here's what would happen if I had subtraction. Maybe we have 3 radical 5 minus 5 radical 5. Well, I know, again, I don't know what radical 5 is. It's just some number. And we would go, oh, well, 3 minus 2, or 3 minus 5 gives me negative 2. And then again, I'm going to just treat radical 5 like a variable. It's just going to stick on at the end. Let's try stuff that has some variables in it. Actually, before we get to variables, let's try to do this. Now, if you try to add this together, you're going to get stuck really quickly. Because you could go, oh, well, I know what 2 plus 3 is. 2 plus 3 is 5. But here's the issue. I don't know what radical 3 is, and I know it's some number. And I don't know what radical 27 is, but I know it's some different number. So if you want to think about this as my variable example, this is kind of like if we did something like we called this x and we called this y. Well, before, if I had 2x plus 3y, we couldn't add those together because they're not like terms. Like, we would leave that. And in this case, we would normally leave that. But because there are some nice things that you can do with radicals, we learned that we could simplify some of these things. So maybe these things simplify and we could really add them. Well, I know radical 3 doesn't simplify. Like, there's no good radical that will divide radical 3. But there might be a good radical that will divide 27. So I want to kind of think about the radical chart that we had before. I know 1 will divide it, but that won't help me. I know 4 won't divide it, but 9 is kind of that winning number. So I know that 9 is what I really want to divide this thing by. So we would know that this thing could be rewritten as 3 plus 9 times radical 3. Well, I know what the square root of 9 is. The square root of 9 is 3. So I'd have 2 radical 3 plus 3 times 3 radical 3. Whole bunch of 3's there. In the next example, probably won't choose as many 3's, but that's okay. 3 times 3 gives me 9. We get radical 3. Now we can do this, because this radical 3 is a like term with this radical 3, and so we know that this would be 11 radical 3. Let's try to do another example of this type of problem. Okay, so in this example right here, we have 3 radical 40 plus 7 radical 90. Again, what I want to do first is I want to break this up, and break this up because I know this isn't a like term with this, so we got to try to simplify it. Luckily, this will simplify down to 4 and radical 10, and this will simplify down to 9 and radical 10. Well, again, I know what the square root of 4 is. It's 2. I don't know what the square root of 10 is, so I'm going to leave it in there. I know what the square root of 9 is. That's 3. And I don't know what the square root of 10 is, so that's just going to be 10. Whoops. A slight error then. The square root of 9 is 3. I don't want to leave it under the radical because we've already taken its square root. Now what I'd like to do is I'd like to simplify some of these things. This would be 6 radical 10. And this would be 21 radical 10. And that would give me my final answer, which we could now add these because these have like bases. And I would have 27 radical 10. What's important in these types of problems is you want to make sure your bases are the same. If your bases aren't the same, you won't be able to deal with this type of problem. Let's do one last example with some variables. So this is one of the most confusing type of problems that you'll probably face, but it's actually very easy to solve. Here's the first thing that I'm going to do to solve this. Again, I can tell that my radicals aren't the same, so I won't be able to add the 5 and the 7x. The other nice part right now is I wouldn't have been able to add the 5 and the 7x to begin with, because these aren't even the same. So like 5 can't add to 7x. So a whole bunch of differences. The one thing I do know how to do is I know that I can simplify this first part. The 3, there is no radical 3 that will divide the 3, but we learned yesterday that the square root of x to the third would really be broken up to be x squared and x. And we know that x squared and the square root will cancel. So what is going to be left, I scroll down a little bit, what's going to be left is 5 radical 3 x and radical x, and we could kind of rewrite that as 5 x radical 3x. Now over here, 7x to the third, well, nothing like will simplify in here, so let's go back to adding 7x radical 3. And the nice part is now we can add these things because these insides are like terms. These outsides are like terms. So my final answer would be 12x radical 3x. Again, we might not know what the inside part is, but that doesn't matter because we know it's some number. And so we just treat it like variables. So all the problems today, you're going to try to simplify some of these radicals. So you're going to try to simplify these radicals as much as possible. And then if they have the same number under the square root, you're going to just treat them like variables and just add the numbers together. So you're going to treat all the problems today very similar to how you treat 5x plus 8x. Or 5x minus 8x. Like you need to check to make sure the x's are the same, and then you just get to subtract the first numbers. Try the different problems today. Again, if you have any questions, please write them down so you can ask them at the beginning of class.